Okay, everyone, I think we're good to go. So we're now going to move on to the satellite track. I'd like to introduce Kieran Arnold, who is Head of Domains at the Satellite Applications Catapult, to introduce your guests.
Good morning, everyone. Actually, I'm Kieran Arnold, as you've been introduced. My title actually is Director of Ubiquitous Connectivity. I'm also the General Manager of our 5G testbed in Buckinghamshire as well. So, just a refresh on the title. I'm actually going to talk to you about another radio system, another wireless system. We generally talk about a satellite, but it inherently is just another radio system we use to connect people on either a local, regional, or global basis. It's not a new kid on the block, although we are going through an evolution in technology within our industry. Some of us, and I consider myself quite old in that, but the first telecommunications satellite launch was actually launched in the year that I was born, in 1962. So, and then the later generations have followed on. We've gone through that evolution over the last 10 years quite significantly compared to other years. Increase in high throughput satellites, the move to terabit satellites, the move into what we're seeing now, given that we're using the word hype in this conference, about the use of new constellations, the use of CubeSats, etc. So we're quite fortunate. We've got two speakers from the industry who are going to talk you all the way through that. I just wanted to highlight a couple of things, really, which are quite important in terms of the satellite industry that's occurring today. One of them is, I'm quite pleased to say, certainly in Release 16 of 3GPP, that we've managed to achieve our first step into what I call real convergence, is acceptance in some of those harmonizations in standards in 5G. So we'll start to see now that move across from what is deemed to be the terrestrial and satellite world to just being another radio system, part of an inherent community of standardizations as well. So I would like to introduce our first speaker from Inmarsat, Yasrine, and she'll talk you through what's happening in our industry and the way things are moving forward as well. Thank you.
Thank you. Hello, everybody. So my name is Yasrine Ibnyahya. I work at Inmarsat within the Chief Technical Office. And I'm sending the apologies of our CEO, Rupert, who couldn't make it today, unfortunately. So to talk about a little bit the role of satellite communication in delivering 5G, I will first of all step back a little bit to explain what satellite operators are doing, and particularly Inmarsat. So Inmarsat, I don't know, how many know about Inmarsat in the room? Oh, okay. Okay, so it's a quite popular, so Inmarsat is a UK-based company in London, headquartered in London. It's a fairly old company, about 40 years old, and it started as an international governmental organization focusing on maritime, particularly for safety purposes. And over the years, we've launched several satellite constellations. Today, we have 3 generations of satellites, so 13 satellites in what we call geostationary orbit, which is at 36,000 kilometers above the Earth, above the equator. And that provides the value of a geostationary satellite is with one geosatellite, you can cover a third of the Earth. So with 3 satellites, 3 Inmarsat satellites, you cover the whole Earth. And through that, we are positioning ourselves as the global mobility satellite operator. And when we say mobility in this case, is really when we are on the move. That's what I mean by mobility. And that means whether you're in the middle of the ocean, or you are in the air on a plane, or you are on the landmass, Inmarsat is delivering voice services as well as data services anywhere on Earth. So about 200 nations are using our services, and our services range from the small messaging type of service, which we call nowadays Internet of Things, to very high throughput satellite service reaching hundreds of megabits per second, to as well providing hybrid networks, which I will touch upon in a minute, related to aviation, European aviation networks. And we also now going into more low power wide area networks where it is needed, because satellite connectivity is not always the answer, and you may want to have heterogeneous network where on one end you're deploying LoRa, for example, solutions, and then you aggregate the data and backhaul it over satellite. So we're fully funded. We're part of the FTSE 250 and with a $2.5 billion mark. And the message here is to say over the last 10 years, the speed at which satellite companies have been innovating has been really increasing very fast. And on average, Inmarsat would spend $600 million of R&D funding in renewing their constellation, investing into new systems, whether it's in space or on the ground, and supporting an ecosystem of product manufacturers. And today, the agenda is very much digital and enabling this digital society. So we operate across 4 business units. Maritime, which is the historical background, and that's why it represents the biggest share of the market, particularly merchant shipping, fishing, offshore energy, passenger vessels with our new Global Express system focusing on crew entertainment and welfare. We have also enterprise. What we call enterprise is everything that happens on land. That's the Internet of Things, that's agriculture, agri-tech, transport and logistics, but also media and aid, as much as smart cities, and we have, for example, a project in Kigali in Africa. Aviation is one of the newest business units. Today represents 15% of Inmarsat's market share, but the reality is it's one of the most growing business units today. It's commercial airlines, it's general aviation and bizjet, it's also safety operations. So it's all really fitting not only the requirements from the air traffic controllers as much within the cockpit, as much as cabin communication and providing passenger with the entertainment they're asking for. And finally, government, which is defense and civil governments, as much as humanitarian and disaster relief type of operation and first response. So the 5G challenges that we all are familiar with today are the same whether you're using terrestrial system or you're using a satellite system. It happens that we have our base station or our E-node B in space, but at the end of the day, we're facing exactly the same challenges as a terrestrial operator would face, which is how do we provide this increasing capacity requirements, how do we address this high-end market as much as addressing this low-end Internet of Things market where we see billions of devices connecting to our network, or at least that's the ambition. And how do we optimize the energy consumption of those devices so they can almost be disposable? You can almost like deploy and forget and not have to get back to it to replace it. So challenges are also happening there, and of course the reliability and security aspect to it. So for us, it's about supporting this, as I was saying, digital society. And we see it as much as the terrestrial world, I would say, which is connectivity almost as a human right. And we see 4 billion people not connected today. And the challenge here is to say, if you manage to bring internet to those 4 billions, then most of the time you will see that you're doubling the GDP of that country just by doing that. So it's really seeing connectivity as an enabler, as the previous panel was saying, providing the right insights for operational efficiency and business growth. And that's what Inmarsat is also positioning itself there. But very often, there is a misconception about what satellite is. Very often we hear satellite is expensive, satellite is slow, satellite is monolithic, we can't really interoperate with it. And even though it may have been true in the past, and not just satellite, all the network may have taken this approach, today a lot of things have changed, and over the last 10 years, a lot of evolutions has happened on that front. So one of the key requirements that the digital society is asking for is, for example, global mobility, so being able to access connectivity anywhere. And that means having this true global coverage, but it's also providing this on-the-move service. So if I give you an example on a plane, for example, or on a ship, When we talk about unmanned ships, autonomous ships, we are collecting all sorts of engine monitoring data and all sorts of health check about the vessel. This is 5G, is collecting all those information, aggregating it, processing it, backhauling it over the infrastructure that is available. And satellites on the ocean, for example, is playing a key role there. And same apply for aviation. The other key requirement is about mission critical. So Inmarsat is positioning itself in providing safety services. So we double, triple our constellations, so we always have an in-orbit backup. But it's also intrinsic to the kind of frequency band we're using. We're operating sometimes in L band, which is very resilient and providing 99.99% availability. And in an era where we're going to have our cars, all our grids relying on autonomous systems, we cannot allow for downtimes. And that's where satellite brings a value, is when you're in remote location, whether you use satellite as a primary mean or secondary mean, it does not matter, but having this ability to always be reliable and use the right frequency band, the right system, is part of the 5G challenge. Longevity is also an important topic, because we see a lot of our customers worried about the speed at which the networks are evolving from 2G to 3G, 3G to 4G, 4G to 5G. And they're worried that their solutions that they're deploying might not be supported in the future. And what the value they see in satellites is our satellites are 20 years lifetime, so they know the infrastructure will be there. And that's reassuring from a customer perspective, because you can truly deploy your product, you can truly forget about it, but you can also maintain it, because satellite provides this over-the-air software capability to upgrade your system. And you do that in a very large scale without having to contact every single device using a broadcasting mechanism. And from a geostationary orbit, you can reach the whole third of the Earth in one go with one message to upgrade or to task any instruction. And that's really the powerful thing that satellite can bring. Another key requirement is obviously resilience and high security. Satellite communication, again here, by nature, have been isolated from maybe the bigger challenges that the terrestrial world has faced, and within Inmarsat, cybersecurity is embedded within the system, whether it's at waveform design, whether it's within the product design, whether it's within the infrastructure. And we can see over time that satellite could not only be used as an alternative system, but also can be used as a secure way of exchanging, for example, public key encryption. So using that as a way of augmenting this security level. Finally, the last point that satellite communication bring is as I was saying, the one-to-many capability, this broadcast system. So for use cases such as connected car, which I will develop in a minute, you can reach all a brand or all the type of software that you want to upgrade with a single broadcasting messages across a particular area. So that's extremely powerful, whether you want to upgrade your sensor, whether you want to instruct an aggregator to do more analytics in one way or another. So you can really do that through a very simple way of handling the content management. And the other powerful things that sometimes people do not know about is that through satellites and this broadcasting mechanism, you can also broadcast GNSS precision navigation. So the global navigation systems such as GPS or GLONASS or Galileo benefits from broadcasting additional precision accuracy files that allow you to go to a high resolution of up to 15 centimeters. And that's extremely powerful when we get to autonomous vehicles as well. And finally, and this topic comes very often, is interoperability. So it's really how do we make every single system click together into one single ecosystem that addresses the society's need. And from our perspective, we are moving away from an era where everybody invents its own standard, its own way of serving the customer, and none of us can individually solve the customer needs because they're becoming more and more difficult, complex, and require lots of specialized skills, and also require a very wide range of skill set from communication to data analytics, and the whole system integration is extremely important. And the ecosystem you try to address for each one of those specific markets is very different. So that's why we believe into collaboration and partnership and build those coalitions to develop a 5G world. So for us, is probably the same as the terrestrial world, which is a step change in the role of the connectivity and dramatically broadening the role of satellite compared to what it used to be a fallback scenario in the past, or a backhauling. It's much more than that. It's really actively present in all the on-the-move systems. So I'm going to share with you two key examples. One is the in-flight passenger connectivity. So today, there's about 5 billion passengers expected per annum by 2025. And all those passengers are expecting to have access to communication in one way or another in their plane. And we're expecting 25,000 connected aircraft by 2025. So the European aviation network that we've deployed, and we are in the process of deploying, is actually a network of 4G base stations pointing towards the sky and augmented by the same spectrum provided through satellites. And this is a very good example that satellites and terrestrial network can share the same core network capability, the same infrastructure to provide a single seamless service experience to the end user. And the London School of Economics issued a report last week saying that about $130 billion revenue per annum are expected from this in-flight connectivity market. Another example is the connected car. If I show you this device, which is a shark fin antenna, you may not know that inside there is an Inmarsat system. There's an Inmarsat antenna. It can receive over-the-air file upgrades. It can send some telematics from the car. It can do some Wi-Fi. So within this shark fin, you already have access to satellite connectivity, and it can do other terrestrial communication systems. So from the end user, this is a seamless experience. The user do not know whether there is satellites in their car or not. What they want to know is they are safe. They can do some e-calling in case of accidents in a remote location. They can have their car checked. They can have software upgraded rather than having to have a car recall. So today we see 60 million lines of code in every car, and this is about to double within the next 5 years. So in order to avoid that and for the car industry to save aside 500 or something like that per car they're releasing on the market in case of recall, this is a huge saving for the industry. And OEMs as manufacturing partners are the ones who can unlock this opportunity by line fitting those kind of capabilities. And by the way, these antennas cost us about $14. So when we get to discussions around cost of satellite, we realize that maybe this perception we used to have in terms of hardware cost, in terms of airtime, when you broadcast an over-the-air file upgrade across a fleet of millions of cars with a single message, we can see now the value of satellite completely changing the economics of this industry. So to conclude, I would say, even though the rocket science part of satellite is fascinating, and we know very well how to do it, actually the heartbeat is not in the rocket science part. It's more around data science. It's more about the analytics and insights we're providing to this customer. It's more about the knowledge we have to have and go so deep in the knowledge of our end user customer in terms of what they're looking for, that is very hard on our own to solve all their issues. And therefore, it's about testing industry per industry, and even within an industry, use case per use case, what are the actual system integration required, because I think the winners at the end of the day will be the ones who are capable of doing this system integration and who are capable of addressing those customers through new distribution channels that the satellite industry, the space industry in general, is not familiar with. So we believe that satellite, with its global, mobile, reliable, secure, and newly capable and cost-effective capability, will be a natural 5G partner to the industry. Thank you very much.
Just want to add a few sentences to that, really, which is just to reiterate the heritage behind the Inmarsat system. Not many people know it is actually a 3G system that was modified as well. Talking about heritage as well, I'd like to invite Dan Mercer from Iridium to the stage and talk about the capability and what's happened, certainly, with Iridium from being its first generation now into the next generation of LEO constellation as well. So, Dan Mercer.
Thank you. Okay, well, hello, good afternoon. I think we're into the afternoon. We are into the afternoon. And let me first of all apologise for my croaky voice. I've been getting over a terrible bout of man flu from having too much fun in Russia last week at the World Cup. So hopefully my voice, and last night, of course. So let's just start off as being the old Leo in the room. I wanted to borrow this Space News double spread, which I think illustrates quite nicely. There's about 15 or so companies that are planning, and we've talked about it a little bit, putting a LEO constellation, internet to the masses, and so on and so forth, up into orbit. And, you know, we know better than anybody that, you know, you've got to create a technological marvel. Not only does it have to work, but you've got to put it through high Gs to launch it into space. It's got to sit in some pretty intense environment up in orbit. So, yeah, okay, that said, there's lots of smart people around that can do that sort of thing. A massive regulatory challenge on where you're going to deliver your services. You need to get, as you all understand, you need to get frequency allocation wherever you want to deploy those services and keep your funders happy while you're doing that. Everything always takes longer than we initially think. But ultimately, and the point I wanted to make here, is that we know, and others perhaps don't have the same memories, the rate of customer acquisition at the end better be fast enough to fund that debt that you've run up to you know, put your system in space. So, you know, there's lots of different aspects here, or lots of different stages. It's brilliant for the space industry as a whole because you know, it's bringing everything to the forefront of everybody's minds. So we're talking a little bit about LEO. Let's talk about our LEO, or use Iridium to illustrate what LEO is all about. We have 66 satellites in a polar orbit. Okay, I think this little video illustrates it quite nicely. You know, there's a whole range of features that, just pushing all the buttons here, that are unique to LEO. Firstly, we're very, very low, 780 kilometers, so that means that the transmit path is very short. We can provide real-time comms from any point on the planet to any other point on the planet at any time. We've got satellite crosslinks. We are just about still unique in that the satellites talk to each other. We don't need terrestrial infrastructure to pass the voice or the data around the planet. We operate in L-band, so good for weather, you know, highly reliable. There's multiple satellites for redundancy. We also have the unique ability of, if you're in a canyon, the network's moving at 18,000 miles an hour across your head, your device, or you as a person, a machine, whatever it is going to be able to get its message out onto the constellation or receive within seconds. Then we're down to the simplistics of, well, okay, omnidirectional antennas mean small power, low, small, omnidirectional devices that you don't have to point in any particular direction. So easy to integrate into all sorts of applications. People, devices, they're moving all the time. You know, power efficiency is obviously about, well, this is all very well, but you need a power budget that the device lasts for long enough under battery. And talking of which, you know, hardware, we've had now nearly 20 years of product innovation. For those of you that, I didn't ask who knows about Iridium, but some of you I'm sure will have heard of Iridium and even used Iridium. And you'll probably know our handsets. So we've maintained a premium position in handsets. You know, it's the Rolls-Royce of handset, omnidirectional, work anywhere type of scenario. We now have location-based services built in, and there's also a version, if you imagine PMR, those of you that know on PMR local, we have a global PMR push-to-talk radio. You can link Afghanistan, troops on the ground, aircraft, London, Washington, they can all talk on the same frequency instantly. So with that, you know, a lot of different pieces of hardware have come out. In fact, CCL has been a major partner of ours over the years here in the UK, developing data transceivers of different shapes and sizes, our little short burst data transceivers. Some of you might have seen 22 millimeters is the square, is the smallest now. We're even into chipset mode as well. And on the satellite side, all software controlled, therefore we've been able to move on with the type of services by reprogramming the constellation to go up to 128 kilobits per second in the maritime and aviation world, and also all the way down and bringing the push-to-talk type of services I just mentioned. Now, I love this slide because we came through the 1 million customer mark, subscriber mark, just a few months ago, but this is a nice image of how the machines and people of planet Earth use our constellation. And I don't know how clearly you can see it, but even if you zoom in, this is 1 day's usage. Okay, so all of those devices, when ping or a voice call or a data call or a 128 kilobits a second data transmission in 1 day. And you can truly see there both the poles are used heavily, and of course, that's with British Antarctic Survey here in Cambridge. You know, in the summer, they're heavy users, as are many, many other. I think there's about 30 other nations that are using our services heavily at the poles. So illustrates very nicely. Last week, I think it was, we processed 6.7 million transmits on the data in 1 day. And in a year, last year, it was 1 billion. So you can start to get the scale of things between familiarity of cellular networks to satellite networks where Inmarsat and Iridium live. Each of those dots is a piece of equipment built by an ecosystem of partners that have some very well-known names, others much smaller, that purchase and integrate Iridium modems, whatever shape or size, into their product, and they build their own complete system selling into their specialist market, a little bit like the GPS chipset into products in the past. So some big names there. In aviation, we have more than 55,000 devices flying around in aircraft. 15,000 of those are in helicopters that have evolved over the years. This is actually here in the UK. It's Bristow Helicopters, S92. They have the UK Coast Guard contract to deliver their rescue services. And it's got, you can see in the yellow circle there, an Iridium Aero Open Port device, which allows the crew to push patient data back across the network, our network, to the NHS on inbound. It also uses Iridium to update on weather into the flight management system as well. So expanding that a little bit further, taking our global technology, just the connectivity as a whole, and then applying the reach and the vision that a huge organization, global brand like CAT can bring to the table, you start to get what we would term killer apps, at least in the satellite industry. And in their words alone, it was a game changer that they integrated Iridium into their devices. These are expensive trucks, diggers, et cetera, all around the world, and become information nodes, allowing different business models to be used to their service departments, to their dealers, to Caterpillar themselves, and to the end user, understanding the through-life effects of what happens to their vehicles, allowing them to steer accordingly. Now, on the consumer side, who has a Garmin device? Quite a few of you. So Garmin have launched with our chipset, they've integrated the Iridium chipset into the Garmin Mini. If you download onto your phone the Garmin EarthMate app, which some of you may be familiar with, I'm sure you're very familiar with the watch as well. All of these integrate together to give. This is mine. Okay, so this is solely Iridium. It's not even a cellular combi product. Tracking, messaging, email, global connectivity. I can actually use with my phone. I can use waypoints. Navigate. You can navigate. There isn't actually much more that you need. It can go in your backpack, hang on your belt. it's beautifully integrated. Again, this is big brands starting to realize the value of what just connectivity means as a whole. So let's talk a little bit about what's been going on. I was here, not here, we were in Cambridge at the time. I think it was 2010 at the Cambridge Wireless event then, and I gave a presentation on Iridium Next. It was coming. This conference is called Beyond the Hype, so I'm trying not to sort of say anything hype-ish today, but Iridium Next is our next generation of LEO satellites. It's a comprehensive $3 billion investment replacement program. Yes, it is fully backwards compatible with the over 1 million devices that we've got out there operating, paying us something every month, which is critical, right? We've retained the low Earth orbit architecture, of course, 66 new operational, more powerful satellites that integrate in orbit, and of course we'll have a few spares in orbit and a few spares on the ground. But the point here is we've done this now with a smooth transition without anyone really noticing in terms of the user community. We've had to do that. So it's going to significantly expand our capability. It's launching right now. What do these birds look like? Just very quickly. Well, for those of you that are techie geeks and know about Iridium flares, where you see the flash across the sky, we've only got one main mission antenna this time, but because it has to be integrated as we've launched into the existing constellation, you can see it basically fits with the crosslink antennas, the feeder link antennas. It just works seamlessly. We also have, it's multi-mission, okay? It's had to work as a hybrid network with our old Block 1. It's got to operate on its own, and it's also carrying a hosted payload Arion. Come and talk to us a little bit later if you're interested in that. But that is ADS-B capturing from the world's commercial aircraft, and military aircraft for that matter, to be able to never lose an aircraft, and overlay as an additional surveillance level for air traffic management systems around the world. Let's now just take a quick look at the fun we've been having with SpaceX, putting our next satellites into space through manufacture, through launch pad, and up into their slot where they're going to spend their life for the next 15 years. So some clips there from actually our launch 4 last December, where most of the population of California thought that the North Koreans had either launched rockets or the aliens were finally invading just because of the atmospheric conditions. So we've successfully completed 6 launches out of 8. We started last January with launch 1. Our most recent was in May, where we did a ride share. You can see how we position the satellites up on the 2 rows of 5 up in the canopy there. We have 2 more to go. Next one is this month, July the 20th. And by the way, if you haven't seen a SpaceX launch yet, either live on their webcast or on YouTube, you've got to do it. It's unbelievable in its own right. Not least from the launch, but seeing the stage 1 of the Falcon 9 coming back down and landing beautifully at the launch pad. So very important partner of ours, SpaceX. And then our final launch will be in the September timeframe, and we are done. What does the network look like today? Okay, this is today. Green indicates new next satellites, and you can see that, you know, we have already 3 completely populated planes. Launch 7 will complete plane 5, essentially, and we have a couple of drifters that we launched over the past 18 months that are coming into position in our very complicated game of Tetris that we've been playing to put the network together. And a fun fact for you, I mean, there's about 1,700, it's estimated, operational satellites in orbit today. There are way, way, way more than that, more than double dead ones as well. But we were up to 97, flying 97 from our control room, a shift of 7 people just recently as we swap old to new. So a pretty incredible feat by that team. With a new network, of course, comes new services, new capability. And whilst our network the new network is capable of 1.4 megabits, kilobits a second speed, we are more focused, actually, in the lucrative. We're a real business here. We have to earn, you know, money to pay for all of this and keep our customers very happy. The 352 to 700 kilobit service, a very lucrative area, that's at launch. But, of course, as we go through the next few 6 months to a year and plus, we'll be introducing our smaller modems again, 22 kilobits a second, 88 kilobits a second up and down, and then the 200 level as well. And a lot of markets that we've been talking about are working with us and pushing to just have that little bit of extra data throughput in the, I wanted to say this, we call it M2M really, but we've said, okay, we can call it IoT, but we know it's not all about IoT. So the M2M IoT area, this is where you know, the key is going to be. Our launch terminals, we're not manufacturing them ourselves. We have contracts with Thales and with Cobham, who are our launch customers. These devices are in final test right now with our partners. And this is a device, if you think about it, 700 kilobits a second, no moving parts, this big, and it work anywhere on the planet. About a year's time, the aeronautical products will be launched with similar partners, Rockwell Collins, GoGo, L3 and Thales, and we are all about not the back with internet access that we were just talking about for passengers. We're all about at the front and safety services. So we have Iridium Next is operating today. I mean, it's up. And our finish line, unbelievably excited about that, is in sight. We have become, and we want to become more, and we expect to be becoming the de facto standard for connectivity anywhere on the planet. That's what our customers and our partners are building towards. Next is going to enable higher speeds, more capability, safety services, which for aviation, for maritime, and land communications. And I just showed you a couple of exciting or very clever high-volume IoT, if we want to call it that, opportunities with Garmin Cat. These things are connecting. So when we started, gosh, 20-plus years ago, we could not have imagined how our network was going to get used, how it was going to blend in to the telecommunications world. And frankly speaking, as Next goes up and goes into service, I think I've heard it talked about a little bit earlier, it's only going to be limited by imagination and coordination and understanding of how all these networks can come together. Thank you very much.
I'm just going to steal 1 minute of your time before I actually open the questions to the audience. And the reason why I want to do that is I actually want to sort of fill in the gap between what we've got from the heritage systems today that have gone through that technology evolution, the speed evolution, the capability evolution, to actually talk about what's happening around with the UK Space Agency and the European Space Agency in and around 5G. I briefly mentioned it earlier on. I started the conversation in this session talking about a radio system. We very much see this as a radio system that we wish to integrate across a 5G ecosystem, certainly supporting the UK's ambition in 5G to be a 5G leader. We're working today on European projects that are looking at convergence in terms of what's happening with software-defined networking and network function virtualization. I can see one of my colleagues in the audience from my directorate, a key partner in that evolution in our ground segment, but also we're challenging what the space segment will be. The mention earlier on from Yasrine about ENOD being space is actually the real thing that we want to aim for. We want to be able to do that technological convergence Actually, the key bit is also the commercial convergence as well, billing, transition of customer. So at the end of the day, the customer is connected or the device is connected, and we can make a service that is ubiquitous in its capability on a global scale. You know, you sit here today, and I see most of you looking at your cellular phones, looking at how ubiquitous our connectivity is. I can talk out of experience, having been 15 years in Orange as Chief Technical Officer for Innovation. It is a challenging area. Radio is challenging to get everywhere. You don't have to do it with one radio system. You can do it with a plethora of systems. It's the integration, it's the convergence, it's the system integration that occurs in a billing later on. So I'm going to stop talking now because I do like the sound of my voice. I'm going to hand over you guys to ask some questions from our speakers and myself. So I'd like to take the first question, if that's all right. Gentleman at the back.
Thanks. My name is Slavomir Pietrzak. I'm from IS Wireless. My question is about the relation between 5G and satellite, because that's sort of an interesting thing. I have seen satellite component starting from late 90s when the Frames project was specifying foundations for UMTS. It was already there. Well, later, somehow, it didn't happen into that extent as we expected at that time. Now, of course, there are various perceptions of 5G, but more or less they boil down to the capacity issue, to densifying the network, to scaling up the network, at the same time lowering the cost of the network, because we would like to have these things happen. So the business model should be changed. Now, how satellite component is scalable? Can we have 1,000 times higher network capacity expressed in bits per second per hertz per square meter? Or, so that also somehow directs to the question whether we should see the satellite as being part of this mainstream 5G debate, or rather as an application for some niches like front haul, back haul solutions. Thanks.
So you want to try? Just briefly, yeah, I think you made the last point, which is about the coexistence and integration in that as well. Certainly in 5G, we don't expect to be, I'd say probably not expecting to compete in the industrial IoT areas, you know, where we need sub-millisecond latency. But certainly with the new constellations coming on board, there is a lower latency offering of that. But in terms of where we see IoT, massive machine to compute, that's probably an area which we look at to augment and extend that reach beyond that as well. Even in a 5G ecosystem, you know, if you take the United Kingdom, there'll be pockets of 5G, there'll be pockets of 4G, there'll be pockets of 3G still in existence for some time, you know, and there are still pockets where we want to do a service deployment that satellite still fits within that quite nicely.
Yeah, exactly. Can you hear me? Yeah? Okay. So to answer your question is we saw, we asked ourselves those same questions in the past, and that's why we see a diverging set of requirements. As you know, there's this high capacity in terms of we want to reach higher throughput, but there's also the high volumes. And to answer your high volumes and in the IoT particular market, from a space perspective, you could, with only one channel of, let's say, 200 kilohertz, you could maybe support 50 million devices at a time using new waveform technologies like spread spectrum and have a very efficient way of handling this sensor to satellite network. Now you can have the other use case, which is more the aggregator use case, which is hoovering a huge amount of data and sending it in real time. And there, that's why Inmarsat took the decision, for example, to go into the Ka band and moving away from the L band, which was highly resilient and addressed very well the low end of the market. But for the hundreds of megabit per second and above, we had to move to a higher frequency band, compromising on the reliability of that band. And it is exactly the same challenge the 5G world has today on terrestrial. And to augment that, It's also about, this integration is also about software-defined network, is bringing those flow of traffic from the IoT, from digital, etc., into a harmonized orchestration and virtual network functions that are handling those type of traffic and are fully integrated with several radio systems. And so the beauty of it is to see for example, the chip manufacturers and etc. bringing this scalability by building devices that are software-defined radios as well. So you can switch from one radio system to another, from one waveform to another, depending on the available link. Yet it's a single billing system, it's a single management system that is fully addressing the 5G needs.
I would add just one small point to that, and that is that, we're operating in L-band, and it's all about, we love applications that hop on and off the network very, very quickly. And so when you talk about capacity, obviously a network has what it has. It's very important that the people that are going to be using that network are well educated and defined in their approach of using the right amount of data on the right type of network. L-band much smaller. As we've seen some 4G and LTE users come across and plug in Iridium, they've had to get their mind around the fact that don't just be thinking about, I'm going to be pumping unlimited, actually data that you can't really use across the network. So there's that efficiency and educated approach to consider as well.
Thank you. Howard Ben from Samsung. I'm perhaps going to show my age a bit here. I actually worked on the base station controllers that Iridium uses a long time ago. I think what most people forget is that Iridium actually is based on the GSM protocols. So this is not the first time that we've had this conversation about integrating satellite and the cellular systems together. A lot of the guys who designed the Iridium system were actually people who helped design the first GSM commercial systems. Anyway, my question is over connectivity to satellite to mobile phones. Do you think there's going to be a use case where the mobile devices that we all use today will actually contain a satellite-based radio chipset for communication? Okay, well, we often get asked that question. Just go backwards a little bit. Some of other of our competitor networks, not Inmarsat, by the way, offer dual-mode devices, satellite and cellular. And honestly speaking, the reality is, we all love our phones. We have everything on it that we want, and if it's in coverage, I'm going to use my phone. I don't want to use satellite phone. So there's that as a background. And certainly our philosophy has been, don't try to, integrate a complex another set of cost into cell phones that are getting reintroduced every few minutes, right? Or every few weeks, shall we say, new versions. So if you look at how we've behaved over the past year, we actually went and say, yeah, sure, keep your cell phone, but let that connect to a very small hub that gives that connectivity. The cost and technology can be managed much better, much more easily. It'll work with any cell phone, rather than thinking, well, do we just put it in Apple? Do we just put it in Samsung? It's kind of a difficult problem to solve. So it's about that hub approach, and Iridium Go has that. There have been a number of others on our competitors as well.
I'd probably reinforce that as well, how it's about that common delivery mechanism to the end user, the device, the customer. It doesn't make sense to go through complicated integration with a chipset into a Samsung phone, for instance. What it does make sense is looking at small cell or densification, where the actual connectivity is a backhaul, and we present a common, standardized, uniformed interface, which is your radio interface on your LTE device or your 5G device as well. That's where it really makes sense. So today we could have lit up this room with an LTE signal if we wish to, by just putting a small base station connectivity onto the roof as well. I'll take one more question from the audience. Yeah, thank you. You've got a microphone.
Okay, Simon from Cambridge Wireless Journal. So a question on costs on Iridium. It's taken 20 years to get to 1 million customers. You're spending 3 billion on a network. That's $3,000 per customer infrastructure cost. How much do you have to charge a customer to be able to make a profit?
Okay.
Yeah.
Well, there's another very important part, and if you look at any satellite constellation, global star, okay, Inmarsat even coming from its governmental heritage, and Iridium, there really isn't one yet that has started from scratch, built up its customers fast enough, at an ARPU, average revenue per unit, that can service the debt and pay for the investment. It's hard. There's been most of these systems, if not all, have been through some kind of bankruptcy and shed that initial debt. We had that luxury, if you remember, but we still invested hundreds of millions of dollars to get to just profitability when Dan Calusi picked up our company back in the beginning of the 2000s. So yeah, you make a valid point, but there is a limit to what you can spend to build a constellation, and this is my sort of initial point. It's very, very hard to put Iridium next together. We had to think, how will people use our constellation in 25 years' time? That's a really hard question to answer, but we've done a good job of that. And with our existing million-plus customers growing pretty quickly, we have a good revenue stream in to support that as a business. So it's a familiar view in the satellite industry. Spend a lot, then acquire your customers. Spend again, acquire customers, and so on. So yeah, I take your point, but that's how we are where we are here today.
If I may augment as well, I would say originally the satellite industry was, as you were saying, a low volume, high ARPU market. And we all, I think, are in agreement with the fact that we have to move away from the kilobit per second or megabit per second, dollar per kilobit per second, because if we stick into that business model, we're following exactly the same trend as the terrestrial operator, which they have to give almost the airtime for free. And so we have to reinvent ourselves into becoming a managed service company and being specialized. If I talk, for example, about agri-tech, we have now hired farmers. We have hired who can help AI developers that will develop the algorithm that meets the sugarcane or berries or whatever type of plantation. And then what you sell to your end customer is not a bit per second, is a solution. And therefore, you not only have to have your system capable of accommodating a large capacity of users, but also move into that value chain into a more fully integrated, whether you go alone or with partners, that's not the point, but it's more really saying you're selling end-to-end managed services.
Thank you. I'd like to just take the opportunity to thank our two presenters today. I would encourage you to certainly talk with Dan and Jensen in the break, or myself. I'm now going to hand over to Faye, but thank you for giving us this opportunity to introduce that alternative wireless system that we talk about as satellite. Thank you.